All right. Good morning, everyone. Welcome to Philly Code Camp 2022. My name is Cameron Presley, and if you have found yourself into being the right session, we're going to be talking about how to build solid software, an intro to design. No worries if you can't catch everything in the session, or no need to really take a whole lot of notes. Everything you need, code samples, the slide deck, books referenced, articles referenced, everything you need can be found in one convenient location. You can go to the link on the slide here, scan the QR code, or if you're watching this live, you can actually catch the same link in the chat for this, but that should have everything you need for today. I'm going to take a moment to talk about what are we really going to be covering. So we're going to start with talking about what is solid. What do we mean by that? And some of the characteristics of solid. We're going to then start breaking it down to why writing solid code can be a good thing, why it tends to give our code certain characteristics that we find favorable. From there, we'll actually start exploring each of the 5 principles a little more in detail by looking at an example bookstore application. So you'll see some not so great code and you'll learn some tips and tricks on how to spot the not good code, how to fix it, things like that, and other things to keep in mind. And then we'll kind of wrap it up from there. Throughout the presentation, I will be pausing and asking Mel to help me out if there's any questions in the chat or anything. So if you do have questions, I recommend putting those in the chat. And with that, we'll go ahead and get into the presentation fully now. So let's start with the foundations, right? Like when we say solid, what do we mean by solid? At a high level, solid is a mnemonic for a set of principles that allow us to write easier to maintain code. The big thing to note here is that these concepts aren't new. Most of these were kind of already identified and started talked about in the late 80s. But all 5 kind of got codified and showed up in one resource, a book by Robert Martin called Agile Principles, Patterns, and Practices. And at a really high level, here's what the solid mnemonic stands for, right? You've got single responsibility, open close principle, list-off substitution, interface segregation, and dependency inversion. I recommend you I do recommend remembering what all these principles mean and kind of their nuances. However, most of solid can be reduced down to your code is probably doing too much and you're probably using bad abstractions. If you remember these 2 key principles, the rest of solid kind of infers itself, which is kind of interesting. So why is solid a good idea? Why do we want to write solid code? Why do we want to write kind of these small things that can kind of compose with each other? Well, when you are reviewing code, right? Like, so you're a developer. That's my assumption here is you're an engineer. You've been writing code, reading code for a while. Where do you spend your time at? Do you spend the bulk of your career reading code, or do you spend the bulk of your code writing code? Feel free to put that in the chat or come off mute and say what you think it is. Like, where do you spend the bulk of your time at? Okay, I understand it's a little bit early. Yeah, so most of the time you're going to be spending a lot of time reading the code, right? Because you're doing bug fixes. And if you're doing bug fixes, you got to figure out what was the code doing before. And I don't know about you, but I've totally had those bug fixes where it took me 4 hours to understand what the code was trying to do, and then a 2-line fix, and then everything was solved, right? Okay, cool. Let's say you do a lot of feature development. Same thing. You've got to figure out what architecture and infrastructure is already in place for me to tie into. Well, you're still reading a lot of that code. So if that's the case, and we think we spend a good chunk of our time reading code, we should probably optimize our code so it's a little bit easier to read. And I like to call this concept time to context, right? So it's the time it takes for me to look over the code and get a rough idea of, okay, here's what's doing, here's what's trying to do. And I found that solid code, for me personally, typically allows me to optimize for that. Because if not, then you run into this situation about where the code's really hard to read. And the other thing to keep in mind too is who's going to maintain your code once you leave, right? Our industry is always changing. People typically change jobs every 2 to 3 years or so. So who's going to maintain it, right? I don't know about you, but I like to leave code in a spot where the next engineer can pick it up and have a pretty good grasp of what they're supposed to do and how to work with it. Because if we don't really do a great job, we end up leaving things like this for our team, where it's this Rube Goldberg machine of contraptions all wired together in a haphazard fashion that somehow, against all odds, actually works correctly, but is a nightmare to really make changes to it. So with that being said, we're going to go ahead and start with the first principle of Solid, which is the single responsibility principle. And really the idea behind this one is you've got something that's just doing way too much, right? It's a Swiss Army knife on steroids. So I'm going to show you some code that seems to be violating this principle. So let's say I've got this class called Order Calculator, and it's got a public method called calculate total, takes an order, and it's going to return the total for this order. Look at this code, and when you think you figured out what it's doing, post it in the chat or come off mute. Just really high level. What is it trying to do?
Anybody?
No, it's a lot to parse in, right? So if you take a look at this method, you see that there's really only two key steps here. One step is it's actually trying to figure out the discount. The other step is trying to figure out the shipping. And then once it's figured out the cost for the discount and the cost for the shipping, then it comes up with some total. This isn't that long of a method, but you actually have to stop and think about this for a minute, right? You actually have to parse through this. It's not very clear. So what could we do? Right. Well, one thing we could do just to make this a little bit more readable is we can actually extract out those pieces of code into helper methods. So in this case, I took all the discount logic, shoved it in a calculate discount method, and then we took the calculate shipping logic and put it in a method called calculate shipping. And this is what our code looks like now. That's a lot easier to read, because now if I look at calculate total, I can immediately see, all right, we get a subtotal, and then we're going to figure out the discount, we're going to figure out the shipping, and here's this. This is really powerful as well, because now if there's an issue calculating the total, I can much quicker figure out where I need to start troubleshooting, right? If it's because the discount's wrong, cool, let me look at the discount logic. Oh, it's the shipping that's wrong? Cool, let me look at the shipping logic, right? I've narrowed down a lot of the troubleshooting I had to do. But wait, I hear you say, this works because calculating discounts and shipping is easy. What if this got more complicated? Cool, no problem. We can go ahead and actually lift those methods into their own classes. Maybe a discount calculator class and a shipping calculator class. And now those classes can be as complex as they need to be, right? But it still doesn't change the fact of what is the order calculator doing, right? The spirit, its intent is still the same, right? So that's kind of what we've done here, is extract out those classes. And if this kind of refactoring made some sense to you, congratulations, you actually understand intuitively what single responsibility is. And at a high level, it's a class should have one reason to change, right? And in our previous example, the main reasons why the order calculator would change is if we needed to add a new calculation step. Maybe there is a loyalty calculator that we need to add, right? That would be one reason. Or we've changed some of the orchestration, but the intent, right? I should calculate the total for this order is still the same, has that one responsibility. So how do we know, like, what are some signs that we can look for that would show that our code isn't really solid, that's not really following single responsibility? Well, a couple of clues is just literally the lines of code in your class. If you crack open a file in your editor of choice and it's measured in hundreds or potentially thousands of lines of code, that could be a symptom that maybe this is doing too much. Another example of another sign that your code's doing too much is how many public methods does it have? If it has, 1, 2, or 3, you're probably okay. If it has 27, probably not great. Another example of maybe why a class is doing too much, if it has a very vague name, like something manager, something organizer, right? Those are very vague terms that usually implies that there's not really a great responsibility carved out of it yet. Continuing on this thread, though, there's another symptom that can kind of manifest itself, and it's classes where there's only one public method, but there are a ton of private methods. I chose 54 at will, but it could be any number past 10, really. And there's an actual name for these types of classes. I like to call them iceberg classes, because on the surface, they seem to be, oh, that's not too bad of a class, only one public method. But once you peer under the waters, you actually peel back the curtains. You go, oh man, there's a lot of stuff going on here. What's happening? So we've talked a little bit about some things you can look out for, and you saw us apply a little bit of those in the previous example, right? Law of lines of code and refactored. So let's talk about the tools. What can we do to fix this? So when you find yourself in a class that's just way too large or you think is violating single responsibility, my first recommendation is break the large methods down to smaller methods. It's really nice when a previous engineer has left a region around the code that says like, oh yeah, this region is responsible for blank, for whatever that thing is. And because in my mind, I go, cool, highlight all that code, Visual Studio shortcut, extract method, and give it the name of the region, right? And that can help start carving out some of this stuff. But once we started breaking the large methods down to smaller methods, we get to make some decisions on, okay, does this private method need to be independently testable, or is this shared logic? And if so, cool, we move it to new classes. Or you might find that it's okay for the private method to live in this class. That's up to you, and that's kind of experience speaking. But let's say for this example, we are going to move it to new classes. That's awesome. What we then need to do is we need to instantiate and inject those new classes back into what was using this logic before. And that's kind of what you saw in the order calculator, right? We extracted logic to a shipping calculator and a discount calculator. And then back inside the order calculator, we just knew them up in there and started using them. So that's kind of the ways we could fix some single responsibility issues there. So I'm going to take a pause and I'm going to check in the chat to see if we've had any questions or concerns so far.
No.
Yeah.
Answers to your first question about what the calculate method is doing.
Okay, cool. Perfect. Well, then we'll keep going and down to our rabbit hole of solid then. So I'm going to break out of script a little bit. We're not going to go talk about the O. We're actually going to talk about D, dependency inversion principle. And the concept behind this one is essentially, would you solder a lamp directly to the electrical wiring in a wall? No, you want to be able to kind of plug and play dependencies as needed, right? And so the principle at a really high level tells us that if our classes, if they're going to depend on anything, it should be on abstractions. So that could be interfaces or abstract classes, depending on your language of choice. In addition, it says that classes shouldn't be responsible for creating their own dependencies. And that's kind of important, right? Because if you have a class that is responsible for creating their own dependencies, that means they need to know about that class's dependencies, and then it turns into this nightmare chain of dependency tree all the way down. So let's talk about when we can spot issues when a class is not really following dependency inversion properly. I'm sorry, I've kind of got ahead of myself, so let me back up a little bit. The reason why this is a problem is because once we started kind of taking these hard line dependencies, right? So I have a class that news up something internally. The only way I can change it out is I have to now manipulate that class, which now increases my risk of things, which isn't great. In addition, it's impossible to write unit tests on this class anymore, because let's say I have a class that does some business rules, and then inside of it, it talks directly to the database. By definition, I can't unit test that anymore because it's talking directly to the database, right? It'd been a lot more helpful to have had some type of abstraction or something else I could have mocked or tested around. Another nice thing about this, about following dependency inversion here, is if you have a class that takes in 10 or 12 dependencies, why is the class taking in that much? Could it be doing too many things? So let's take a look at some code that kind of doesn't do a great job on this. So back in our bookstore application, we've got this class called email notifier. It knows how to notify someone based on the message, right? So this is the workflow of someone's completed an order, and now we're going to send them an email notification, let them know that like, hey, we've got your thing, right? So the problem is right here. If I wanted to unit test the order completer, complete order method, I can't unit test anymore because the email notifier is going to send out real emails. And unless I'm wanting to set up my own inbox and then test email accounts, this isn't really tenable. And also, funny enough, the complete order class, it actually doesn't care if the email got sent. It just cared that, hey, did I tell you to send an email? Right? So, and if, let's say I wanted to switch out the way I wanted to notify a customer that an order completed, I can't actually do that very easily because I would have to come in here and kind of rip out some of this logic, put in new logic. Also, I'm kind of lucky that the email notifier is a really simple class because it only needs an email address. What if this had other dependencies like servers or HTTP addresses or whatever? Now all of a sudden my order completer needs to know about how to send an email, and that's a single responsibility violation, right? It shouldn't have to know how to send an email. That's why we have this class to do it. So there's all sorts of code smells going on with just this one line of code, which is kind of interesting. Let's keep going though. Let's say that I now have a class whose sole job is to keep track of when things have changed in the database, so we've got some type of audit trail happening here. Well, the problem I've got in this class is the fact that I've got a public static logger that I'm using in the database audit trail writer class. And that's problematic because whatever that logger is going to do, it's going to do. So if it logs to the database, it's going to log to the database. If it logs to a file, it's going to log to a file. And there's no way I can separate out that logic, right? It's going to go do that. And that can really be a pain in the butt when trying to write tests on this stuff. So how can we fix some of these things, right? Like how, now that we can spot these problems, how can I fix it? Well, we've got two goals that we got to be able to do. The first thing we've got to be able to do is make sure that we can even pass the dependency on. And that seems counterintuitive, but we'll talk about why that may not always be easy. And then the second thing we need to do is we have to make sure that the dependency itself has some type of abstraction, whether that is an interface or a base class or what have you, depending on your language. So to make a class really injectable, you've got to make it not static if it is, right? So if the class is static, you got to make it not static. And then once you've done that, you need to define an abstraction. And if it doesn't have one, you're going to have to define one. And then once you've done those two things, you can inject this dependency either through the constructor or through a method. And you'll see both those approaches in this presentation. But some of you engineers who've been doing this for a while may have seen that I just kind of skated over that first point. If the class is static, make it not static. Anyone want to take a guess on how easy or hard that task could be? Do you think just removing the static keyword would work? Or do you think that could cause other problems?
That could probably cause other problems.
Oh yeah, especially. Thank you for coming off mute, right? So if you have a class that's static and it's used everywhere and you then remove the static keyword, you've essentially broken the code base over your knee. And that's because static classes can sometimes do this to your code base, right? Once you start using statics, it can make other things static, and then you start running into problems. Now, that being said, I love using static classes and static methods for business rules, for things that never need to talk to databases or networks or APIs. Those are awesome. But the minute I start crossing those boundaries, man, doing that in a static class is such a bad idea for the most part. So what do we have? So what can we do, right? Because we can't just rip off the static keyword. We're going to have to figure out a different way. And the reason why we have to make it non-static is because if it's a static class, you can't pass them as parameters. They just are. They just be. And static classes can't implement interfaces or base classes. So you can't inject them, and they don't have abstractions. So we're kind of busted in both ways. So how do we get rid of the static cling? I've mentioned it. If you can remove the static keyword, great, go do it. But most of the time you can't. When you can't, you're gonna have to use something known as the wrapper pattern. And what the wrapper pattern tells us is that we will define another class that's not static, and it literally wraps around the static one and then we use the wrapper to pass as the thing to inject. And I'll show you that right now. So here is our example where we had the static logger, good old friend here. And we're going to start refactoring this a little bit. So step one, I'm going to define an interface that has all the public methods of that static class, which we do right here. Since our static logger class only had that one log method, here's how we implemented it, right? So it's got the same log method, same signatures, same everything. Once we've defined that interface, what we can do next is we're going to create a new class that implements that interface. And typically, I like to call the class whatever thing we're wrapping wrapper. So that's what we have here, public class logger wrapper. It's going to implement iLogger. The minute I say this class implements this interface, I then have to provide a definition for everything. So I can do that easily enough because what we can do for each method's implementation is to literally call the static class. This approach is really nice because now I have a way to inject a static, but I can be deliberate on when to do this, right? I can now clean as I go instead of breaking the entire code base over my knee in one shot. And if it's a dependency like loggers or database access, things like that, this is a really nice approach. But now that we've got a logger wrapper, and we've now got an interface and abstraction, we can now think about how do we inject these things. So when I usually coach other engineers on the subject, I typically talk about constructor versus method level. And the real differentiation between the two is, would it make sense for this dependency to change while this object is kind of in existence? For example, if you're working on a web API and you're taking in some type of repository or something that does data storage, you're probably not changing that out mid-flight, right? Whatever your data storage is, it's going to be the data storage while that API is running. Constructor level makes a lot of sense there. On the other hand, if I was writing, let's say, a calculator and I wanted to add two numbers, I probably wouldn't want those numbers to be at the constructor level because that means if I ever wanted to add two different numbers, I would have to create a brand new calculator, and that seems wasteful. So going back to our logger, right, I'll put it out to the audience here. Do you think we would change out the logger per invocation of write audit trail? Or do you think, whatever the logger is, it's probably what we're going to be using throughout the entire lifetime of the audit trail writer?
It'll change, or you can substitute it with something else besides the logger, or like there's a possibility.
Yeah, so we could switch it out, but typically speaking, you don't usually switch out from like a file logger to, let's say, a database logger in mid-flight. Usually whatever logger you're using, that's what you're using. So I think there's a little bit in the chat, someone mentioned constructor, bingo. So that's what we'll do. We will add a new constructor here. So private read only iLogger. Here's how we'll inject it. And now that we've injected it at the constructor level, we can then, oh, sorry about that. Wrong button there. But once we've done that, we can then just straight up use it in the right audit trail. For those of you playing along at home wondering, but Cameron, you just added a new constructor that now takes a mandatory like parameter. Won't that break everything? It can, but another way you can get around that is you can still give the database audit trail writer an empty constructor. And then as part of that constructor, it'll actually daisy chain into this new one. And what it'll do is it'll pass in a new logger wrapper. So depending on how much technical debt you're willing to take on and how much refactoring you can comfortably do, my recommendation is to do what we just did, right? Just put a brand new constructor in there, have it inject in. If that's too critical, let's say you do this and now you've broken the code in 50 million places, then the empty constructor trick and then have it daisy chain into the new constructor, that'll work just fine. Just realize you'll need to clean that up at some point. Make sense? Yes, no, maybe. No one shouted me off, so I'll take that as a yeah. So We've talked about loggers. Let's go back to one of our previous examples, our email notifier. Right, so this was the bit of code, right, that when we complete an order, we then have to notify the customer that, hey, we've done this. So let me ask the question to the group. Let's say that the customer can change how they like to be notified, right? Maybe they like to be notified via email, maybe text messages. Heck, man, maybe it's smoke signals. Because the way they like to be notified can change, do you think we should inject the notifier at the method level or at the constructor level? Yeah, I'm seeing it in the chat here. So yeah, method level, right? So what we'll do is we will add a new parameter to complete order that takes in an I notifier, and that's the key here, right? We're taking in that abstraction, not the hard dependency. The implementation of that abstraction. So we're taking in that I notifier, that email notifier already had, and then we're just going to say notifier.notify, and that's it. And this is really convenient because let's say now I needed to add a new notification type, let's say smoke signal, create a class, have it implement the interface. I can inject it into complete order. There we go. Also doing a shout out here, let's say that for whatever reason you couldn't manipulate the signature of complete order. You can do the exact same trick I talked about earlier where you have another public void complete order. It just takes in an order, but then what it does under the hood is it then calls out to the more complex version of complete order, but then passes in the email notifier as a parameter. So you can still kind of do that method overloading trick a little bit here to kind of help you contain how much you're about to break. So here comes the fun part. If you were able to understand and hold on to most of what we've talked about for single responsibility and dependency inversion, you've got 80% of most issues you're going to find to a code base when we talk about like code quality and testability and those types of things. Because the other three principles, open close, list off, and interface segregation, you typically trip into those because you violated either single responsibility or dependency inversion. And you'll actually see that through the rest of this presentation. It's still good to know about those things, and that's why we're going to talk about them. But if you left this presentation and you only really understood single responsibility and dependency inversion, that's already going to give you a massive leg up in most code bases. That being said, I'm going to take a pause here to see if there's any questions in the chat or anything else we need to talk about. Okay, I'm not seeing anything in the chat, so we'll keep moving. So let's go to open close principle. So I don't know about you all, but I loved Malcolm in the Middle growing up, and this is one of my favorite scenes. So Hal is trying to go fix a light bulb in the garage, and to do that, or in the kitchen, and to do that, he's trying to get a light bulb, but he knows that the shelf's busted. And then throughout that show, he realized that the shelf's busted, so he goes tries to fix the shelf, but what he needs to fix that's not missing. So then he goes out to the garage to find it, but something in the garage is not working. And then when his wife comes home and asks him, hey, did you ever fix that light in the garage? You see him underneath a car switching out the transmission, and he screams back, what does it look like I'm doing? I chuckle at that because sometimes it reminds me of relationships I've had with product owners when I've been like deep in the guts of trying to fix something, and they're wondering, hey, Cameron, why isn't this one simple thing fixed yet? And it's like, well, yeah, I'm working on it. Can't you tell I'm all the way over here? When you find yourself in code bases like that, typically what's happened is that there's an open close principle violation. Let me show you. So you may recall earlier in the presentation, we talked about the shipping calculator. And so we've got this class shipping calculator. It says, given an order, I'm going to come up with some business rules for you. Right. So in this case, if the order is going to the state of Missouri, here's some stuff. Otherwise, here's some other logic. Right. But you know, product owners, you know the business, they always want more stuff. So they come up with a brand new feature that they want you to implement. And it's actually based on the number of books, right? So if someone orders less than 3 books, then we need to do this different logic for shipping because of whatever reason. Cool, so we implement it. I don't know about you, but this class is already starting to get to that point where this could get really complicated, right? Because let's say the business then says, oh, we want to also have different shipping if it's more than 10 books. And oh yeah, we want different shipping if the customer is a loyalty member. And oh yeah, we want different shipping because of such and such and such. This class could all of a sudden start becoming a massive nest of if, else if checks, right? So the problem that we ran into here is that if I wanted to change the logic on how to calculate shipping, I had to crack open and change this method. And the minute I change this method, I have to now make sure I didn't break logic somewhere else. Now I'm lucky because right now the class is ifs and else ifs and all that. And because of such, it's a little bit easier to troubleshoot. However, that's not always the case. I don't know about y'all, but I've definitely been in code bases where massive switch statements or 500 lines worth of decision logic to come up with something, and touching any of those things has always been risky because then you have to regression everything there. So what open close tells us is that we should be able to extend classes easily, but we shouldn't have to be able to modify them. And the reason why we want to do it that way is because adding new functionality by adding new classes is actually a pretty low risk, right? Because if you add a brand new class that handles your functionality, it's pretty rare that you're going to break an existing one. So let's take a look into why this is kind of a big deal, right? We don't like modifying classes to add functionality because it can break something downstream, which isn't great. And open close forces us to add that functionality by creating new classes and then using an abstraction. Here's the abstraction word that we've talked about earlier today. And then once we've got that, it's always safer to create this new class and inject in the behavior. And so I'm going to show you that real quick using what we've done. So we're going to be leveraging the factory pattern. And so what this is going to turn into is we're going to have a class whose sole job is to make the decision of which type of shipping rules to use. And then that's how we'll leverage this. So we'll update the original shipping calculator to be a factory. The people using the shipping calculator will now use the factory. And then you'll see in a couple of slides what that looks from a business logic perspective. So here is our current shipping calculator class as it stands today. What we're going to do next is we're going to go ahead and create this new interface called IShipping Calculator that has a method called calculate shipping given an order. And then we're going to create some new classes, right? We're going to create the Missouri shipping calculator, fewer than 3 books, a default shipping, and we can continue creating as many other business rules as we need. Back in our original shipping calculator, we've made a couple of changes. Instead of running the actual business rules in here, we are going to instead return back the calculator that is being consumed, right? So if it's Missouri, we're going to give you this calculator. If it's less than 3 books, we're going to give you this calculator. Otherwise, we're going to give you this other calculator. And now that we've done that, we can go back to our order calculator class, change it up a little bit, says that needs a factory. And now when we're doing the calculate total workflow, we can say, hey, shipping factory, give me that shipping calculator. At this point, it's pretty rare that I've broken something because I've added a new dependency in the constructor, but we've already talked about ways you can handle that. We're already returning back the same logic essentially that we were using before, right? Shipping calculators, we're already doing that, right? And we did that through the way we extracted the interfaces and such. So at this point, it's pretty rare that I've broken something in all of this workflow. But what's nice about this refactor is now take a look at what we would do if we had a new calculator, right? So let's say someone came in and said, hey, I need a new shipping logic for loyalty. Cool. I create the loyalty shipping calculator, have it implement the interface, implement whatever business rules it needs, and now the factory would return the new calculator based on whatever criteria. And the order calculator now, the one that says here's how much your order is, that didn't change. I didn't have to modify that at all. That's pretty slick. Seems like I've got a question in the chat, so I'll take a pause for it. So Jeff asks, you pass the order in and the factory inspects the properties to determine which calculator to return. Yes, that's exactly right. So uses the properties to figure out which calculator to give back, and then the order calculator itself will then say, all right, cool, I'll use that calculator to figure out the shipping costs. That's exactly right in this case. Great question there, Jeff. So I'm going to take a pause here to see if there's any questions or anything about open close before we go to the next one.
Hey, just
Okay.
just to follow up on that. So
Yeah, sure.
what's the difference between that and then just passing the order in and having the order or the, I guess in this case it would be the factory just calculate the shipping.
I could have done it that way.
Okay.
Yeah. No difference. The bigger thing, though, right, is just making sure that the order calculator now no longer has to inspect all the different types of calculators, which is something that it was having to do before. And also now the shipping calculator factory is responsible for knowing which thing to use.
Okay.
Yeah, you got it. Another question in the chat. Too much logic in the factory itself. How to separate it further? So talk to me a little bit about that, because the factory at this point would only be responsible for knowing, based on this criteria, go return this dependency. So it's really just kind of an orchestrator at that point.
But still, you're kind of trying to avoid put too much logic in one place. And here, all your logic, and it may be depending on shipping and on royalty and on something else. Then you kind of, you put everything in this factory. So
yeah. So let's talk about that then. So I'll go back up a little bit. So the factory itself, all it's responsible for is saying, given an order, which logic, like which calculator should I return back? So it's not actually calculating the shipping for, okay, if it's Missouri, I'm going to go do that map. It's just going to give you back the class that's responsible. So even if we were to expand 10 more rules for shipping, this would have essentially 10 if-else checks is what this would look like.
right. So in a way, you kind of moved problem from one place to another. I understand that's a pattern, but if you think about it, right, you still have all your problems in factory, because now like single change there and it also can break.
I'm not 100% sure I agree with that, but we can talk more after this if you want to. Yeah.
Thank you.
Yeah, you got it. Thinking on my feet a little bit here, one thing that you could do is you could add the logic for if the calculator would apply or not as a method on the shipping calculator itself. So maybe you had some bool method that says is applicable. And then all the factory would do is it would run through the list of calculators it knows, finds the first one that says it's applicable, and then use that. I don't really like that approach, but you kind of putting me on my feet, that would be kind of like my first stab at it. And then at that point, the factory would become really, it'd be a very dumb component, right? Because it would just be looping through.
Yeah, that makes sense, yeah.
Yeah.
And sorry, one more question for those calculators, right? Different calculators. If there is a common logic, would you still recommend that they have some ancestor class? Right? They can have common ancestor or no? If there is something common between
Oh, sure. Yeah. Yeah, if that's the case, go for it. Not a problem. There's nothing stopping a class from inheriting from a base class and implementing an interface.
Thank you.
Yep, you got it. Great questions. So we'll keep it going here. So for Liskov substitution principle, at a really high level, it's if it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. I'll see if I can get the GIF to work here, but I always like it, right? Because these chickens are kind of in their habitat, and then this new things come in, and they're like, I think this is a chicken, but I'm not really sure because it's not moving its head, and then they're kind of inspecting it a little bit, trying to figure out what is it. And you're like, cool, that's chickens. Cameron, what does Liskov have to do with anything of code? And I'll show you. So back in our bookstore app, we've got a concept known as a book, right? Big shocker. And it's got some properties, right? Author, title, some ISBN number, and a price. And then we've got this inventory manager class. And it's got a couple of things it can do. It can tell you if a book can be ordered, and it checks the warehouse. And then it's got a way to update the stock. And what it does is it removes certain things from the warehouse. Right. Funny enough, the business rules don't really matter here. Just realize that we've got some way to keep track if we have books in stock or not. But you know what? I hear ebooks are kind of cool. So product comes down and says, hey, we've got to do ebooks. Ebooks are like the wave of the future. We got to make it happen. So you go, all right, cool. You talk to product and they tell you like, oh yeah, an ebook has an author, it has a title, still has an ISBN number, still has a price, and you go, cool. So an ebook then is like a book. So I'll go ahead and make that dependency. So I'll say an electronic book is everything, inherits from book, has all those things. Here's where we start running into a few interesting issues, is that now I can write code like the following, where I can create the inventory manager, create a new ebook, but then I can do things like this, where, hey, inventory manager, can I order this? Do I need to update the stock? And that gets a bit weird because it's like, well, it's ebooks. Where are you checking them if they're in stock? Right? Because we essentially have an infinite supply of them. That doesn't make any sense. So what we could do is we could fix this problem by going into the inventory manager and doing these types of checks where we pass in that book still, and then we inspect its type and go, okay, well, if it's an electronic book, we just immediately, bail out and say return true, right? Because it's always true, right? The problem though now is I have to sprinkle this type of logic all over my code base, which is not great. Right, like that just doesn't work. And this is kind of the hint. If you're having to inspect the type of the dependency you're passing in and then run different logic, you're probably using a bad abstraction. And that's what Liskov really tells us. So typecasting to perform logic is bad, right? Because that's not really sustainable or extendable. And this actually leads to this concept of leaky abstractions. Jeff Atwood of Coding Horror fame has a couple of blog posts about leaky abstractions, why they're not super great. And to me, this is also not an awesome thing to run into because it means I can't lean on the compiler to find my errors for me. It would have been really cool for the compiler to have prevented me from passing in an ebook to the inventory manager. That would have been really nice, but it can't do that with the way we solved it. So what could we do instead? In this particular case, we have discovered that not all books are created equally. What if we change, though, the way we did our abstractions? So let's go back to our book example. Author, title, ISBN, price, no problem. Electronic books are books, but now let's introduce this new concept known as a physical book. So, right, this is going to, so we have two types now, an ebook and a physical book. They both come from book. But now the minute we do this, we can strengthen the type system on our inventory manager and say, oh, you want to order a book or update the stock? This only applies to physical books now. It can only be physical books. And the minute I do this, I can now no longer pass in ebooks. I can't do it because the code will fail to compile. I love it when the compiler tells me I'm about to violate some business rules. I hate it when it tells me I forgot a semicolon. So anything I can do to improve the type system to help me catch business rules or domain rule violations, oh man, I'm really excited about that. So, I've clicked one button there. Yeah. So Liskov, kind of going back to this, what it tells us that if we have two classes and they're derived from the same abstraction, then I should be able to interchange them. And I shouldn't have to care about the type of class for the abstraction to do the work. That's really what Liskov is. So I'm hoping this kind of clears it up a little bit, and maybe you can start thinking about maybe some interesting parts in your code base that could stand to rethink about this. The other hint I can give you is that sometimes you can't find a good abstraction. Right, and at that case, you kind of have to do what you can. But when you can find a better one, go for it. All right, I'm just doing a quick time check here to see how we're doing. Great, we're doing perfect. So I will go ahead and roll us into the last part of solids to talk about, which is the interface segregation principle. which is essentially you. So in this kind of graphic, you want me to plug this in where? And really what the problem is the following. So let's go back to our inventory manager. It's got a couple of methods. Can book be ordered, has an update stock method we've already talked about, but now it's got an order more method. So we've added that. Now back into our add physical book to order, recall that's a new feature we've had to implement. I can do inventory manager, right? And I can say can book be ordered, and it does the logic as it's supposed to. But something else I can do inside this method now is I can tell the inventory manager to order more books. I probably shouldn't be able to tell the inventory manager to order more books here, right? Because what I'm wanting it to do is just update some inventory. I don't want it to order more from a distributor or from a publisher or whatever, right? And the reason why I can do that is because I newed up an inventory manager. And the minute I do that, I have access to everything it can do, which is probably not what we wanted. And let's talk about why that's not a great thing. What we run into is that we can find out what our dependency can do, but not what it should do. And Martin Fowler actually has a really great series of blog posts on this when he talks about header interfaces versus role interfaces. For those of you who come from like a WPF or WinForms versus desktop development experience for sure, there's definitely been times where I've been working with one of the UI controls, and then so I type in the name and I hit dot, and IntelliSense gives me 5 million and one things that this thing could do, and all I'm really trying to do is send her some text, right? It's because there's no great abstractions there, right? It just gives me everything. So what we're trying to propose here is when we're defining our interfaces and our abstractions, it shouldn't just be a full list of everything it can do. It should be more of, okay, if you're using the class in these roles, here's what you can do as part of that role. Let me show you. So what we've discovered with our inventory manager is it's probably doing too much, to be honest. And the fact it's called manager should have been our first red flag, but that's okay. But what we've discovered is that this inventory manager really has two roles. One is to track inventory. So what we're going to do is we're going to create an interface for that role specifically, and it's going to list those specific methods as part of that interface. We'll update the inventory manager so it implements that new interface, and then we'll update the client code to use that new interface. The minute we do steps 3 and 4, we've now limited the scope that you can interact with the inventory manager in. So like the following. So we've created this new inventory tracker that's got can books be ordered and update stock. Because it uses the exact same signature as what we had in inventory manager, we can easily have this class implement that interface, no problem. That's a safe refactor. And now in our add physical books to order, we can hard type this thing to be an inventory tracker. And in fact, if we're following some of the other principles of Solid, maybe we would inject this at the constructor level as an inventory tracker. But now that we do that, we can only use these methods. I can't use the order more from distributor method anymore. It doesn't exist, right? Because it's not on that interface. This is a really great technique when you're working with classes that are massive and you can't carve them apart yet. Right, so going back to single responsibility where we maybe you do have a class that's got 50 public methods on it. Maybe your first approach is you break down which roles that class is being used in, and then you can create those interfaces. There's nothing wrong with a class using multiple interfaces or implementing multiple interfaces. That's not a problem. C# will easily handle that. So you can kind of use interfaces as a great way to slim down what you expose to callers. And that's what interface segregation is really all about. So I'm going to take a pause here to see if there's any questions or concerns or comments. Okay. Well, with that being said, we're going to go ahead and wrap up a little bit here. So over the last 15 minutes or so, we've spent some time talking about what Solid is. Set of mnemonics, mnemonic for a set of principles that usually leads our code to be a little bit more maintainable, a little bit more testable. We talked a little bit about why our code should be solid, some principles, how to spot issues, right? How do you know you're looking at how to spot code that's not great, a couple of ways that you can fix it, and actually developing a language to talk to other engineers about how to fix it. But recall, if you don't remember every single thing we've talked about the last 15 minutes, if you just remember that all the violations come from doing too much and bad abstractions, that will lead you well on your way. Some resources I've called out that I definitely want to give a shout out to. Working Effectively with Legacy Code by Michael Feathers. If you don't have this book, please go buy it. It's a great how-to book of if you, it's kind of like a follow your own adventure path book of, I can't test my code because it's doing too much. Here's some way, and you go to chapter 7, it goes, oh yeah, here's how you break that. I can't test this code because it's all static. Cool, use the wrapper pattern. It talks about how to do that. So that book is fantastic. Refactoring by Martin Fowler. I originally called out the original version, but the second edition also does a really good job, so I'll call that one out. If you're more of a video person, I found Solid Principles of Object-Oriented Design by Steve Smith to be fantastic from Pluralsight. And then I called out the blog post about role interfaces from Martin Fowler. All of these and more are found on the link I posted into the Teams chat, and you will find on the YouTube description of this video once it gets posted. And otherwise, that's it for me. So I appreciate you all joining me this morning at Philly Code Camp. Had a great time. And I see I have one more question in the chat from Jeff about where did the order books go? So that's a great question. That method still lives on the class, still there. It's just because it wasn't listed on the interface, it's not exposed as such. Mentioned the YouTube channel at the very start. Where can I find that? Yep, so Philly Code Camp actually has a YouTube channel where all the sessions for this Code Camp will be posted there in at a future date. I don't know if Mel is still on the call or not, but yeah, he can provide. Oh, cool. Mel, can you help me out a little bit?
I'm here, and Bill will send out that email after Code Camp of where you can find all the videos. But if you look for Philly.net and on YouTube, there's a bunch of content there from our previous meetings and previous Code Camps.
Perfect. Thanks, Mel. Oh, got another great question in the chat. Liskov substitution principle example. How does this relate to the prefer composition over inheritance advice that is sometimes said? Why would you choose inheritance approach to your book example, physical book and ebook or books, instead of using an approach with interfaces? You could easily have done that as well. If you wanted to go down the interface route, you could have. That's not a big deal. I just chose the bigger one was let's talk about abstractions. Right, so I know my classes were a little bit more simplistic, but let's pretend that there was still some shared common logic, then base classes may have made sense. But you could have also done an interface there. Hopefully that helps. All right, I'll give it a few more minutes, see if there's any other comments or questions in the chat, but otherwise, man, I'll be chilling out here for the next little bit.